Hey guys, this is Jack. I just wanted to share something really quite quick with you all. I'm pretty excited by this actually. I've got a weapon that I've been developing, and this weapon is going to be sort of like one of the big powerful weapons in my game, and it's going to have like a special AI assisted missile which you can just fire off into any direction, and then it'll just automatically find the best location to go to explode to get as many kills as possible. All of the logic involved is pretty straightforward, but there's one component of the weapon that is not straightforward, and that is basically how do you find a path through a 3D environment from start to finish without hitting any objects, and how do you do this? How do you write this in a way that it can be used in like any 3D environment at all? So, like let's just say, for example, if I spawn, I might be like over here in the corner of my map, right? And then I might just, let's say I have the weapon, and then I fire it, and the weapon has to go and find other people. So let's say we have a person who's, all the way over here on the other side of the map, right? And somehow the missile has to find this person, and it has to navigate. It has to be able to navigate through all of this complicated geometry in order to find them, right? So simple use case. So originally when I first started designing the idea, I looked into the way that Unreal was doing, bot navigation. So they have like a navigation mesh, which sticks to all of the floors. And then it sort of does like a 2D pathfinding, which is pretty simple. But that wasn't really going to work for me because, I have a 3-dimensional world and a lot of the surfaces are not flat. So this code needs to be able to navigate an environment that is completely dynamic, and it has to be able to find the shortest path, and it has to be able to do it quickly. So I looked into pathfinding, and I found a couple of algorithms that were pretty useful. So one of them is this A-star algorithm. This was designed quite a few decades ago, and it's really good for finding the shortest possible path between 2 points on a set grid. And all you need to give it is, grid points that are either solid or not. So in this image, like these white boxes, these are valid and the red X's are not valid. And then as long as you give 2 points within that grid, and as long as there is a path between those 2 points, a possible path, the A-star algorithm will find a path using some pretty simple heuristics. In most cases, the heuristic that you can use is, the 3-dimensional or the 2-dimensional distance between your current position and the position you're trying to get to. To show you how the algorithm works, if we play this through, these green boxes represent available points. The blue boxes represent unavailable. The white boxes represent the voxels that are being searched by the algorithm. And then as it searches, it'll eventually find the shortest path through the available grid points. So this is a 2-dimensional implementation, and this is extremely fast. We need 3-dimensional, but the A-star algorithm still works in 3 dimensions, and we've been developing a system to do that. So I've got this Pathfinder volume in my level here, and this Pathfinder volume is essentially a massive volume that we just draw out, and we make sure that the volume encompasses the entire map. And then once we encompass the entire map, we've got these custom C++ variables here to set the dimensions of the grid that we're going to generate. So let's just say here we have 150 by 150 by 50. Now that's quite a few voxels. Like if we calculate that, 150 times 150 times 50, we end up with 1.125 million voxels. Now, as long as you don't need to display those voxels, which we don't, all we're doing currently in our class is we're just querying the world with these voxels, and then we store the state of each voxel it's either solid or it's not. And then we basically wrap all of those voxels up into a grid, into an array, and save the data. So we have these functions down here, load graph. So if I just bring my log over here and go load graph, it's calculating. Cool. So now it's finished. So it took 3 seconds approximately to do 1.125 million intersections. And then it saved all of that data in RAM. And now we can use that data to basically find paths. So I've got these start and end points here. So if we go up here and we have a look, we have this start point up here. We have an end point, which is over here. So if I just go and frame that guy. So let's go put this where we spoke about before. So I'm just going to go bring this all the way over here. Cool. So that's my end point. And over here is my start point. And yeah, so if I just select the class and go find path, bam, look at that. Path took 0.002 seconds to generate. So, this line here basically represents the algorithm's attempt at finding a short path between those two. So right now, the algorithm is not optimized to the point that it will find the absolute shortest path, but it will find a very short path. And those optimizations, we can program those in pretty easily. This is just like a first implementation, which is pretty cool, right? Like, it's quite cool. So, the important thing is that it's completely dynamic. So, like if I come and grab this start transform, let's say I'll just bring it somewhere else, like, bring it down here into this part of the map. And again, just go find path. And then now it's found a completely different path. It's still going, looks like it's still going the same way up here. Oh no, so it's going through here now. So it's calculated that this is actually a shorter distance to get to the end goal. So yeah, super cool. So, the way that I would imagine this weapon class working once we start implementing the projectile is like, let's just say I'm carrying the weapon and I'm kind of running around. One mode is going to be like a direct fire, so you can fire it in a straight line, and it's basically does like a huge area of damage. But the other mode is essentially going to be like the AI mode, where, I could just fire it up here and then it'll just automatically find the best position that it can go to cause the max damage, and then it'll just start navigating towards that position. And it's going to do like, we're going to do path smoothing and a whole bunch of cool effects to sort of, just really sell what it's doing. And I think as well, like the whole concept of like a blue shell from Mario Kart kind of zipping around the level in 3D, kind of finding its way to get the best possible kill, I think is really cool, and we can sort of program a whole bunch of logic into the weapon to sort of make it, if it's a capture the flag map and someone has the enemy flag, it'll obviously prioritize that player to go and kill them before they capture the flag. If it's like a domination map where we're trying to capture objectives, if one of our objectives is being captured, it'll automatically navigate to the best possible player that it can find to get the best kill. So there's a whole bunch of like really cool, intelligent logic that we can build into the weapon. And the other thing I should probably say is that the weapon will navigate through doors. So doors will automatically open if the projectile tries to head through them. So, currently the logic is set up so that if we do try and navigate through a door, the weapon will automatically realize that, and the pathfinding algorithm will be okay heading through a door. So like if I put, let's say I put start point over here, and then I go and grab my end point, and let's just say I'll just snap it here or something. The algorithm should just go through the door. Yeah, so it's automatically recognizing that it can go through doors, and then that also feels pretty cool, right? Like the missile will be able to open doors and travel through them, and yeah. So yeah, I just thought I'd share that. The pretty exciting little coding success. All of the logic is currently in C++. So like all these custom, like these buttons that we have in the editor, like load graph, that's all being done in this C++ base class here, this load graph. You can see these functions are calling in editor, unloading the graph, finding the path, etc. And then if we go to the definition of these functions, yeah, it's all just being sort of, all of it being done in C++ because there's quite a bit of calculation intensive stuff needing to be done. And, you know, down the line, I would imagine that this weapon will be constantly finding paths, like even as it's navigating, it'll be constantly pinging the graph, seeing where players are, should it update its path and go in a different direction, you know, because it'll be super intelligent, so it needs to constantly be scanning the environment so it knows the best place to go to get the maximum kills. But yeah, super cool, super promising, and looking forward to actually developing this weapon. I think it's going to be a lot of fun. Cheers.